Hello dear student. So in my previous video we have discussed about electric potential energy, right? What is electric potential energy? It is the energy needed to bring a unit positive charge from infinity to that point. Energy needed and total work done in bringing unit positive charge from infinity to that point is electric potential. So work done is the electric potential and the energy needed to do that work is the electric potential. And today we'll start with expression for electric potential energy of a system of three charges. So in previous video we seen about expression for electric potential energy of the system of two charges. So today we'll discuss about system of three charges. Now see, consider three charges Q1, Q2 and Q3. So using these charges you have to generate a system something like this. Now see, this is a three charge system. So to construct these three charge system, so Q1 here, Q2 here, Q3 here. So work will be done, right? And how much work is done and how much energy it required, that you have to calculate. And that work or that energy is the electric potential energy, right? So in previous video we have seen about only these two charges, right? How this system of two charges Q1 and Q2 formed, right? So we'll discuss today by adding one more charge, that is Q3, right? Now in last video what you have seen, we have considered the empty space. Imagine this space is empty now, there is no charge. Now bring first Q1 from infinity to this point. What will happen? Work will be done, right? And how much is the work here against the electric field? It is zero, right? Work done in bringing this Q1 charge from infinity to that point is a zero. Why? Because there is no external electric field in the beginning. So there was no electric field, that's why in bringing a unit positive charge Q1 from infinity to that point is a 0. So W1 is the 0. So what is your next aim to calculate? So you have calculated now this work done to bring this charge, right? To bring this Q1 charge, how much work it needed, that you calculated. Now again it is you have called it as W1. Now calculate for W2, right? Now calculate for W2. W2 is the work done, right, in bringing a charge Q2 from infinity to this point, right? Calculate how to calculate W2, right? To calculate that W2 you have to consider an equation according to definition of electric potential, right? In last equation last video you have seen, right? What according to definition of electric potential, what is V is equal to W divided by Q, right? V is equal to W divided by Q. Now suppose if you want to calculate work done, then transfer this Q this side. What will become? W is equal to, what it becomes? W is equal to Q into V, right? W is equal to Q into V. So now you want to calculate a work done at this point. See, at this point you have to calculate work done, right? Here it is W2. So W2 is the Q into V you seen. So how much is Q here? Q2. So W2 will be Q2, right? So how much is the potential here? That is important, right? V means potential at this point. So how much is potential here, right? You have not brought this charge yet, only charge Q1 you have brought, right? Due to this charge Q1, some electric potential will be there at this point. Call that electric potential as V1, right? Now see here, it is the work done in bringing charge q2 from infinity to that point. That is w2 is equal to q2 into v1. So v1 is the work done, right? So v1 is equal to what? 1 divided by 4 pi epsilon naught, right? q1 divided by r12, right? w2 is the, sorry, v1 is the 1 divided by 4 pi epsilon naught q1 divided by r12. R12 is the distance between charge q1 and q2. See here, r12 is the distance between charge q1 and q2. So due to this charge q1, potential here will be, right, you know the equation, right? Electric potential due to point charge, right? So that v1 is equal to 1 divided by 4 pi epsilon naught q1 divided by r12. It is the equation, right? So that is equation for v1. So into q2, this extra term you have to add q2. So work done v2 will be what? 1 divided by 4 pi epsilon naught q1 divided by q2 divided by r12. It is the work done in bringing charge q2 from infinity to the position r2, right? So you have calculated w1 and w2. So next you have to bring charge q3, right? You have to bring charge q3 also. So in previous video you have brought only two charges, that's why I calculated w1 and w2 for two charges. So this derivation is for three charges, right? This derivation is for three charges. So next w3 is also comes. So w3 is the work done, w3 is the work done in bringing charge q3 from infinity to that point. Now look at the diagram here, look at this figure. So this charge you have to bring from infinity to here, q3 charge. So at that point, work done, if you want to calculate, you have to multiply your charge into potential at this point. W is equal to qv, you know. So you should know the potential here first, right? Q is the value of charge is the q3, you know. So you have to calculate only v, that is potential, to calculate work, right? So how much is the potential at this point? See, at this point there are two charges influence, right? One is q1, another one is q2. These two charges affect some electric potential here, right? Not only one charge, both charge q1 and q2 both will affect some electric potential at this point q3, right? So due to charge q1, how much will be potential, tell me? Again as same as here, right? That is 1 divided by 4 pi epsilon naught q1 divided by distance is r13. Again according to this v2 q2, how much is the potential here? That is 1 divided by 4 pi epsilon naught q2 divided by r23. So total potential at this place is potential due to q1 plus potential due to q2, right? So v1 is equal to 1 divided by 4 pi epsilon naught q1 divided by r13, and v2 is the 1 divided by 4 pi epsilon naught q2 divided by r23. See here, and call that potential, total potential, as v12. So v12 is the total potential at charge q3. So that is 1 divided by 4 pi epsilon naught q1 divided by r13, right, plus 1 divided by 4 pi epsilon naught q2 divided by r23. If you take this 1 divided by 4 pi epsilon naught common, you will get this equation: q1 r divided by q1 divided by r13 plus q2 divided by r23 is the potential at where? At a point q3. It is the potential at point q3. So you have calculated the potential there. So work done will be how much? Work done will be w3 is equal to your q3 and this potential, that is v12, right? So w3, see here, w3 will be this much. So this is the work done in bringing charge q3 from infinity to that point. So You know the equation for value of W13, right? Sorry, V13, that is potential at point Q3, and multiply that potential with charge Q3. You will get the work W3. Substitute the value of V3. Substitute the value of this V3 from previous you have calculated, recently you have calculated V13, right? That is potential at point Q3. Substitute that value in this equation and multiply that with the Q3. You will get total work done to bring third charge, that is Q3, from infinity to that point. So W3 is the work done. So now how much will be the total work done to construct that overall figure? Overall figure means Q1, Q2, Q3. How much will be the work done? And that total work done is equal to your electric potential energy, right? And that for total work W is equal to W1 plus W2 plus W3. W1 will be W1 will be what? W1 will be work done in moving charge Q1 from infinity, and W2 is the work done in bringing charge Q2 from infinity to that point, and W3 is work done in bringing charge Q3 from infinity. So these are the total work done, and that total work is called as a U, capital U. What is this capital U? It is electric potential energy. Electric potential energy is represented by capital U. So total work done is equal to electric potential energy. So substitute the value for W1, W2 and W3. You will get equation for electric potential, right? So value of W1 is 0, or substituted. Value of W2 is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12, right? And plus value of W3 is 1 divided by 4 pi epsilon naught Q1 Q3 divided by R13 plus Q2 Q3 divided by R23, right? So take out the commons once again. So 1 divided by epsilon naught, 1 divided by epsilon naught common, take out, and you will get a final equation as U is equal to 1 divided by 4 pi epsilon naught bracket Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. So it is the total equation for total electric potential energy of a system having three charges, right? So for two charges you have calculated two work, that is W1 and W2. W1 will be 0 because in the beginning there is no external electric field to do the work against, right? There is no work will not be do against the electric field there, because in the beginning there was no charge in that system while bringing that charge Q1. That's why work is 0. And while bringing charge Q2, there is some electric field due to charge Q1, right? And while bringing Q3, there was some electric field due to both charges, that is Q1 and Q2. So according to that cases, you have calculated work done W1 plus W2 and W3, and to get a total electric potential energy, what you have did, you have added all those work. So you got electric potential energy for a system of three charges. So further things we'll see in next class.